Top 5 Quantum Physics Myths Debunked. Quantum physics. It sounds mysterious, mind-bending, and maybe even magical. You may have heard that particles can teleport, that observing things changes reality, or that quantum physics holds the secrets to time travel. But how much of what you hear about quantum physics is true? In this video, we're diving into the top 5 myths about quantum physics to separate fact from fiction. Let's get started. Have you ever heard the saying, "A watched pot never boils"? In the quantum world, it's more like, a watched particle never decides where it wants to be. The idea that simply observing something in the quantum realm can instantly change its reality stems from a misinterpretation of the observer effect. It's true that in quantum physics, the act of observation, or more accurately, measurement, can disturb the system being observed. Think of it like this. Imagine trying to measure the air pressure in a bicycle tire using a standard pressure gauge. When you attach the gauge to the valve, you inevitably release a tiny bit of air, which slightly changes the pressure inside the tire. Similarly, in quantum physics, the tools and methods we use to observe or measure particles at such small scales inevitably interact with them, influencing their properties like position or momentum. It's not that our conscious observation is magically changing reality, it's that the act of measurement itself, with the tools at our disposal, introduces a change. This is because quantum particles exist in a hazy state of possibilities until they are measured. So, while the observer effect is a real phenomenon in quantum mechanics, it's not about our thoughts directly influencing reality. There's a common misconception that quantum physics is confined to the microscopic world of atoms and subatomic particles, a secret realm that has no bearing on our macroscopic, everyday experiences. It's true that quantum effects are most pronounced at these incredibly small scales. But to think that quantum mechanics is limited to the microscopic is like saying, the rules of gravity only apply to apples falling from trees and not to planets orbiting stars. Just because we don't directly see quantum effects in our everyday lives doesn't mean they're not there, working their subtle influence behind the scenes. Take superconductivity, for example. This phenomenon, where certain materials conduct electricity with zero resistance at extremely low temperatures, is a macroscopic manifestation of quantum mechanics. The electrons in these superconductors pair up in a special way, dictated by quantum rules, allowing them to flow effortlessly without any energy loss. And then there's the development of quantum computers, which exploit the principles of superposition and entanglement to perform calculations in ways that classical computers simply can't. So, while it's true that quantum effects are more apparent at the atomic and subatomic levels, their influence extends far beyond the microscopic realm. Myth 3. Quantum particles can teleport. Now, who wouldn't want to teleport? Beam me up, Scotty! It's a staple of science fiction, and the idea of particles effortlessly zipping across space and time is undeniably cool. But can quantum particles actually teleport like in the movies? Not quite. The confusion often arises from two fascinating quantum phenomena: quantum tunneling and quantum entanglement. Quantum tunneling is a bit like a ghost walking through a wall. Imagine rolling a ball up a hill. Classically, if the ball doesn't have enough energy to reach the top, it rolls back down. But in the quantum world, there's a small chance that the ball can mysteriously appear on the other side of the hill, as if it tunneled through. This happens because, in quantum mechanics, particles don't have a precise location. They exist as waves of probability. Then there's quantum entanglement, which Einstein famously called spooky action at a distance. This is where two particles become linked in such a way that they share the same fate, no matter how far apart they are. If you measure the state of one particle, you instantly know the state of the other, even if they're light years away. So while quantum tunneling and entanglement are mind-boggling in their own right, they don't involve particles teleporting in the traditional sense. Myth 4. Quantum physics means everything is random. Einstein's famous words, "God doesn't play dice with the universe," reflect a deep discomfort with the probabilistic nature of quantum mechanics. It's tempting to think that because quantum events are governed by chance, the universe is inherently random, unpredictable, and governed by pure luck. But here's the thing. While quantum mechanics introduces an element of probability, it's not the same as saying everything is utterly chaotic and unknowable. In fact, quantum mechanics is incredibly precise in its predictions. It's just that those predictions are about probabilities, not certainties. Imagine flipping a coin. You can't say for sure whether it will land on heads or tails, but you know there's a 50-50 chance for either outcome. With enough flips, you'll find that the results tend to even out, following a predictable pattern. Quantum mechanics is similar. We can't pinpoint the exact location or momentum of a particle, but we can calculate the probability of finding it in a particular state. So, while the universe at the quantum level may seem fuzzy and uncertain, it's not a free-for-all of randomness. Myth 5. Quantum physics proves parallel universes exist. The idea of parallel universes, where countless versions of ourselves are living out different lives in alternate realities, is a captivating concept. It's fueled countless science fiction stories, and thanks to certain interpretations of quantum mechanics, it's a topic that often bleeds into scientific discussions. One of the most popular interpretations that seems to support the idea of parallel universes is the many worlds interpretation. This mind-bending idea suggests that every time a quantum measurement is made, every time a quantum roulette wheel spins and the ball lands on a specific outcome, the universe splits, creating a separate branch of reality for each possibility. In one universe, you might have ordered pizza for dinner. In another, you went for sushi. As enticing as this sounds, it's crucial to remember that the many worlds interpretation is just that, an interpretation. It's a way of trying to make sense of the mathematics of quantum mechanics, but it's not the only interpretation, and it's not without its critics. The main problem is that we have no experimental evidence to support the existence of these parallel universes. So, while the many worlds interpretation is a fascinating thought experiment, it remains firmly in the realm of speculation. And there you have it, 5 myths about quantum physics debunked. Quantum mechanics is strange, exciting, and complex, but it's not magic. Next time someone tells you that you can change reality with your mind or that particles are teleporting everywhere, you'll know the real story. Thanks for watching. If you enjoyed learning about quantum myths, don't forget to hit the like button and subscribe for more fascinating science videos. Leave a comment if you have any questions or other myths you want us to cover.